Good morning once again. I'm here to discuss the chemical properties of metals. In my previous class, I discussed the physical properties of metals. I talked about sonorosity, that is, giving out ringing sound when they are hit. I talked about malleability. Metals can be hammered into shape. I talked about lustrosity. Metals are shiny when freshly cut or when sandpapered. I talked about hardness. Metals are hard, which is the reason why they have high melting and boiling points. I talked about metal as being good conductors of heat and electricity. They allow heat and electricity to flow through them easily. Yes. And I also talked about ductility. Metals are ductiles, they can be drawn into shape. Now today I'm going to be talking about the chemical properties of metals. We have various metals mentioned, but since I'm dealing with grade 7, I'm going to be picking few metals and talking about their reactivity. Metals, they react the reactive metals react with oxygen. The reactive metals include sodium, potassium, magnesium, calcium, aluminium, up to zinc to some extent. They are very reactive. Zinc is mildly reactive. I take them again. Sodium, potassium, magnesium, calcium, and aluminium. They are good or very reactive metals. They react with oxygen on exposure. When these metals are exposed to oxygen, they easily react with oxygen. And when you burn them in the presence of oxygen, that is in air, they also react quickly. When sodium reacts with oxygen, sodium forms sodium peroxide or sodium oxide with oxygen. When magnesium is burnt in oxygen, it forms magnesium oxide. But sometimes when magnesium is exposed, the reaction takes a longer time than when it is burnt, when magnesium is burnt in oxygen. When magnesium ribbon is exposed to oxygen, over time, the shiny appearance starts fading. And that is why you remember when I said metals are shiny when freshly cut, and I said the exposure over a period of time, the shiny appearance will fade away. This is due to the reaction of the metal with oxygen in air. Metals react with water as well. Yes, metals react with water differently. Some, they react with cold water vigorously, annoyingly. Example is sodium and potassium, violently with water, cold water. Magnesium, what about magnesium? It also reacts with water. Calcium also, but in this case, their reaction is slow, a slow reaction. Aluminium also. What about zinc? Zinc reacts with water, but not cold. Zinc reacts with steam, that is water in gaseous state. Yes. What about copper? Copper is also metal, but does it react with water? No. Copper does not react with water, which is why it is safe for use as a pipe, because the water passes through it without reacting with the pipe, so your water is safe. It does not contaminate your water. That is for copper. Now, what about their reaction with acid? Sodium, potassium, calcium, they react violently. It's not even advisable to carry out such reaction in the school laboratory because of the hazard. Yes, because of the risk involved. Copper, sodium, potassium, and calcium. But you can react with acid, whether dilute acid or concentrated acid. You see the reaction. Yes, good. Now coming to corrosion reaction. Corrosion reaction has to do with reaction of mostly iron metals. Yes, not all metals corrode. So we have, let's make use of iron. Rusting of iron is corrosion reaction. And what are the factors necessary for this rusting of iron? Iron rusts. Iron will not react with oxygen alone in air. Iron rusts. Rust is formed when iron reacts with oxygen and water. The water can be in gaseous form or in liquid form. So these are some of the reactions of metals, chemical properties of metals. They react with oxygen, they react with water, they react with acid. They can corrode. Yes, some metals can corrode. Talk about the reaction of metals. Right? Now let me talk about the reactivities of these metals, the trend. Magnesium, potassium is the most reactive of all, followed by sodium, then magnesium. I hope you're with me. Okay, potassium, sodium, calcium, magnesium, aluminium, zinc. Yes. Then iron, tin, lead, copper, yes. Then I talk about silver, then we talk about gold. I deliberately omit mercury for a reason. We'll talk about that in my next class. Yes. From potassium down to gold, the reactivity decreases, meaning that potassium is the most reactive of all. Thank you so much. Until next time when we meet again, have a wonderful night rest.